Okay, good day, students. How are you all doing? All right, in this class, we're looking at kinematics in physics. All right, this course is for all science students, those in secondary school, those preparing for JAM, all right, those in university. Okay, I shall be discussing about kinematics in physics. Kinematics is actually a branch of physics that deals with the study of motion of a body without considering the forces that causes the motion. All right. The word kinematics talks about how objects move from one point to another without considering the force that causes the motion of the object or of the body. All right. We know that in practical that force causes motion, right? But if we are to talk about kinematics, we neglect force. Force must be neglected before we can talk about kinematics. So kinematics can be grouped into two. We have what we call the 1D kinematics motion and the 2D kinematics motion. We have the 1D and the 2D. The 1D talks about the linear, we have the linear kinematics, which involves motion in one direction, okay? Then the 2D talks about two-dimensional motion, which involves motion that occur both horizontal and what vertical. One that talks about horizontal, like a car traveling from Abuja to Lagos. This is called a 1D linear kinematics. All right. So in kinematics, in linear kinematics, we talk about we say that it's an aspect of physics, right, that deals with the study of motion of a body without considering the forces that causes the motion. Now, there are some key concepts we must have to take note in linear kinematics. Key concept. The first key concept is called displacement of the body. Displacement of the body. When you hear the word displacement, it talks about the change in position of the body, okay, from one point to another. So displacement is giving us change in this. So displacement is giving us change in x equals s final minus x initial. S minus x what? Initial. So this is called our displacement. When you subtract the initial displacement from the final displacement, we have the total displacement. The next concept we shall talk about is called distance. These are the key concepts. Distance talks about the total length covered when the body moves from one point to another. Both displacement and distance are measured in what? In meter. They are measured in meters, meaning they have the same SI units and they have the same dimension. Dimension for displacement and distance is simply capital what? L. Any quantities in physics that has each unit in meter has a dimension of capital L. So displacement and distance are of the same dimension, which is capital L. The next concept I want us to look at is called velocity. Velocity simply means change in displacement over change in time. Right? Our change in displacement we have already seen is giving us s final minus x initial over t final minus t initial, right? Our s final minus s initial, which is our change in displacement or displacement with respect to what? To change in what? In time. Change in time means final time minus initial time. Another key concept I want us to look at, which is called speed. Speed is defined as the rate of change of distance, rate of change of distance, or distance over what? Over time. Distance over time. Total distance covered or total length covered when the body moves from one point to another with respect to the time. Okay? The motion of the body is covered. That will give us speed. Distance over time. When the body moves from one point to another, the body moves through a distance with respect to time. So when you divide your distance over time, that will give us speed. Now the next concept I want us to look at, the final concept, is called acceleration. It's called acceleration. Acceleration of the body. When the body accelerates, it is defined as change in velocity over change in time. Change in velocity over change in time. This is giving us v final minus v initial divided by t final minus t initial. Right? In most cases, we use the word v to represent final minus our initial is u, then divided by what? Our change in time. So V represents final velocity, U represents initial velocity, then our change in time represents our change in time. Okay, alright. It means differences between the initial time and the final time. Alright, so let's look at some good example from your textbook. Then we look at some other exercises across other textbooks in other universities. Alright, so we have a question that says that if a particle is displaced from initial position S1 is 16 meters at T1 equals 2 seconds, right? So S2 equals 4 meters at T2 equals 6 seconds. Now we have to find the displacement and the average velocity for this time interval. We have to find the displacement. Now the first thing that we are giving our first displacement as 16 meters. This first displacement is called our initial, right? This is our initial what? Displacement. Okay. Now we have at this displacement our time is T1, our time is 2 seconds rather. It's 2 seconds. This is our initial time, right? Our initial what? Time given. Okay. Now it is being displaced from this to S2. Our S2 there was given us 4 meters. This is our final displacement. Final displacement, right? Okay. Now at T2, which is what, 6 seconds. So my T2 is what, 6 seconds. This is called my final time. Final time. Now we have to find the displacement and the average velocity. Displacement, we know displacement from the formula I gave us in the previous explanation is given as change in x equals s final minus x what? Initial. Right? So yeah, our s final is actually 4 meters, right? We have 4, okay, minus our s initial is 16 meters, right? Okay, divided by, oh sorry, okay, by the time we subtract this will give us minus 12 meters. This is our displacement. Number 2 says, find the average velocity. We have gotten the displacement, so let's find the average velocity. Average velocity, we know, is giving us change in displacement over change in what? In time, right? Okay, in this case, don't forget that we say that our change in displacement is displacement, final displacement minus initial what? Initial displacement divided by what? Our T final minus T initial. Already, we have already solved our final displacement, our change in displacement as minus 12. The whole of this we got minus 12, right? So here will give us minus 12 divided by our T final. Our T final is actually 6 seconds. Our T initial is what? So we have 6 minus 2. So this will give us what? Minus 12 divided by what here? 4. The final answer here is divide 12 by 4. That will give us about 3 meters per what? Seconds. Yeah, 3 meters per second. But here we have negative sign. We're going to have minus 3 meters per second. Minus 12 divided by 4 is minus 3 meters per second. So this is how simple this kind of question can be. Now let's see another example 2 from the same textbook. Okay, the next question says that how far does a torque go in 5 seconds if the average velocity is 80 meters per second? Solution to this, here we have to find the displacement. 2 key things are given here. We have velocity and we have our time, right? We have velocity, which is given as 80 meters per second, and we have our time, which is given as 5 seconds, right? Okay, there's a formula connecting velocity, time, and our displacement, right? Our displacement. We have to find how far does a torque go, meaning what is the displacement covered or distance covered, right? Go in how many seconds? 5 seconds. If the average velocity is what? Is 80. Now, our average velocity is given as 80, our time is given as 5 seconds. Then we now look at this. How do we solve this? We have to look for a formula that connects these 3 things together, that connects velocity, that connects our time, We also connect our displacements. So the formula is simply this. We have to recall that velocity is equals to displacement over what? Over time, right? Okay. But we have to find displacement. So what do? We cross multiply. We cross multiply. We cross multiply. So displacement, okay, which represent our x, is equals to velocity times time, right? Our velocity in this question is actually 80, right? 80 meters per second, okay, times our time cover is 5 seconds. This will give us 400 meters, all right? 400 meters. So another way we can solve this, velocity is giving us 80, right? 80 meters per second, okay, multiply with 5 seconds, right? 5 seconds. So seconds can go with seconds. We are left with what? 80 meters times 5, which is equals to what? 400 watt meter. You can either solve with the unit involved or without the unit, but just note that at the end of the day, your displacement must be measured in meter. Alright? So let's see another example from your textbook. And let's look at this question here. We are told that if the displacement of a particle along a two-dimensional plane, the word two-dimensional simply means this that the body moves both horizontal and vertical. All right, that's called two-dimensional plane. Okay, is given by r equals 80 square I plus btj. Are you seeing it now? I and j. I represent the x-axis, j represents the y-axis. That's called two-dimensional. Now, what is the instantaneous velocity of the particle at t equals to 2 seconds? This is very simple to solve. Now, I want to take us back to what we call calculus. Okay, calculus. Under this, I'll be talking about a little on differentiation. Okay, differentiation. Please pay attention. The word differentiation simply means to find the slope of an equation without plotting a graph. It's used to find the slope or the gradient, right? Now we know that slope is given as change in y over what? Change in what? X. Is that also? That's called slope. I want us to go back to our formula I stated earlier. We have velocity, which is equals to what? Displacement, right? Displacement over what? Over time. Is that not? Okay. That means that for velocity, I can say that a change in displacement over a change in what? Time will give us what? Velocity. What does that mean? When you differentiate displacement with respect to time, you're going to have what? Velocity. I will show us how to differentiate. Differentiation is very simple. If you understand the concept of differentiation, you understand what I'm about to do here. Alright? Now, just know that velocity from the formula we stated says that velocity equals what? Change in displacement over change in what? In time. Alright? There's what we call acceleration, right? Acceleration is A, which is equals to our change in velocity over change in what? In time. Meaning when we differentiate the velocity with respect to time, that will give us what? Acceleration. Alright? You will need this concept to be able to solve this problem because we are given our displacement. If the displacement out of a particle is given by r equals to what? A t square I plus b tj. What is the instantaneous velocity? That means this equation concerns this. It concerns this equation here. Is that not so? We are given displacement, which is our r or x. Okay? With respect to time, if you look at this expression very well, the value of r is with respect to what? To time. Displacement equals to a t square I plus b tj. Alright? Now, let me show us briefly how to differentiate an equation so you can know how to solve this problem. Now, look at this very well. Okay, in differentiation, the general form of differentiation, we have the general form. We have several forms of differentiation. We have several forms of it. But the first and foremost, you all should know to solve this is actually the general form. General form, if I have y equals to ax raised to power n, the general form says to differentiate, to find the y dx, it simply means that change in y, right, over change in x is equals to what? I'll multiply this power here by the coefficient of this f, which is a, meaning na, right? Then subtract 1 from the power, which is n minus 1. For instance, If I have y equals to 2x raised to power what? 4. 2x raised to power 4. To find my y dx, changing y over changing x. Why are we doing changing y over changing x? Because the two variables we have in these expressions are what? Y and x. So a little change in y over what? A change in x should give us, by the time we apply our general principle, the principle says what? Multiply this power with the coefficient of x and subtract 1 from the power. The power here is say 4, right? 4 times 2 will give us what? Yeah? 8. 8s raised to power what? I will subtract 1, which is 4 minus 1. And that will give us what? Yeah? 8s raised to power what? 3. Let's see another good example. What if I have value of r equals to, let's say, 2t raised to power 3 plus 5t squared. And we have to find change in r over what? Change in what? T. Change in r, change in displacement over change in time. Most of the time, they will use the value of r to represent displacement, or use the value of x, or just a normal one, x, right? Now, in this case, we have r representing displacement, and I want to find the velocity of this motion, okay, of this two-dimensional motion. Because this is a two-dimensional motion. If I have here to be I and here to be what j, it becomes what? Two-dimensional motion. So to find my change in r by change in s, from this principle I just taught us here, the power here is what? 3, right? 3 times 2 will give us what? 6. 6t. Then the rule says, when you multiply the power by this, you subtract 1 from the power. And that will give us what? 3 minus 1, which is what? 2i. Plus 2 times 5 is what? It's 10. Are you there? And that will give us what? 10t, 10 to the power 1, or in what? In g. Is that also? I repeat this again. 3 times 2 is 6. 3 minus 1 is what? Is 2. 2 times 5 is what? Is 10. When you subtract 1 from these two, we have what? 1. So this is my displacement. So this is my velocity of the motion of the particle. Now let's look at how we can import this knowledge to solve this example. Okay, now, if the displacement r of a particle along a two-dimensional plane is given as this, we are given the value of r to be equals to at square I plus what? btj, right? And we have to find the instantaneous velocity, meaning find velocity, right, of the particle at t equals to about 2 seconds. Very simple. So what we need to do is to find my velocity, instantaneous velocity. Velocity will give us what? Change in displacement, right? Over what? Change in what? Time. For what I've taught you so far, the principle of differentiation says what? When you differentiate, you multiply the power by what? Coefficient of this x. Then subtract 1 from the power. What is the power of t here? It's 2. I'm differentiating displacement with respect to what? To I, to t rather. That means I will consider the power of t on both terms or both equations. Now let's solve this now. This will give us what? 2 times a, right? Will give us what here? 2at. What is 2 minus 1? Is still 1. So my answer is what? 2ati, right? Plus the power of t here is actually 1. And that will give us 1 times b will give us what? b. bt. Yeah, if I multiply this 1 by coefficient of this t, and subtract 1 from this 1. Initially, the power of this t is 1. So what is 1 minus 1? The answer is what? Is 0, right? 0 what? Yeah? 0j. So finally, this becomes what? 2a ti plus bj. Why do we have bj? Because t raised to power 0 is 1. Any number raised to power 0 is actually unit, is 1. So t raised to power 0 will give us what here? 1. But don't forget that we are told that our a is half. Our b is what? Is 2. So I'm going to put the value of a as half. That will give me 2 times half ci plus our b is 2. That will give me 2j, right? So to solve this, our final answer becomes, when we multiply 2 by half, 2 here 1, 2 into 2 will give us 1. That will give us what here? Our velocity will give us ti plus what? 2j, all in meter per second. But recall that our time is what? 2 seconds. Our time is 2 seconds. So I'm going to replace my t with 2. So now my velocity will be 2i, right? plus what, yeah? 2j, all in meter per what? Second. Okay, what we just did here was to replace our time here. We don't have time here again because our time here has been replaced with 1. Because t raised power 0 is what is 1. Okay, so from here, that will give us what here? 2I plus what? 2j in meter per second. Now let's see another good example on this to understand this concept further. The next question says that if the displacement of a particle along two-dimensional plane is given as r equals to 2t cubed I plus 5t squared, find the average what? Velocity. Now I've taught you this already. To find my average velocity we're going to say our formula is what? Change in what? Displacement over change in what? Time. And that means what? Okay, so what we do is to differentiate this, right? I will differentiate r with respect to what? T. So what's the principle here? Multiply this 3 by 2, right? That will give us 6t. So I will subtract 1 from this power 3. That will give us 6t raised power 2i, right? Okay, plus 5t squared, which is 5 times 2 will give us what, yeah? 10tj. Is that not so? So 3 times 2 is what? Is 6t raised power 2. Then plus 5t squared will give us what? 2 times 5 is what? Is 10. Then when you subtract 1 from 2, that will give us 1. This is the final answer here. Alright? This is the final answer. Except, what if they say, find velocity at t equals to what? 1 second. 1 second. So what do? Is to find our average velocity. Just say recall that velocity is given as what? Yeah? 6t squared I plus 10tj. So from there I can find my velocity when t is 1 second. That implies that v1 will give us, it simply means anywhere we see t, I will put what? 1. That will give us what? Yeah? t, 6 times 1, all squared I, right? Plus what? 10 times 1j. This will give us what here? 6 times 1i plus 10 times 1j. So yeah, we're going to have here to be 6i plus what? 10j. Okay guys, so thank you so much for watching my video. I just want you to do me a favor. Just click on the bell. Like and share to your classmates and all that, to your classmates, and tell us in the comment section which particular topic or which particular course you would like us to talk on or to teach. If you have any challenges in any topic, just mention that topic in the comment section and expect the video of that particular topic. Thank you so much. I love you guys. Thanks.